Welcome to Matcom. In this particular video, we will be discussing one important aspect from NCERT Chemistry class plus 2, Haloalkanes and Haloarenes. This question is very important. This question has been asked many times in the previous year board examinations. So before starting this particular class, we would like to say that there are various playlists are available in our channel relating to mathematics, physics, chemistry of class 10 plus 1 plus 2. Those who are interested, please check out those videos. The playlist will be, please check out our playlist. The details of the sum of the videos will be given in the description box. As a token of gratitude, please like to this particular video, share with your friends, subscribe to our channel. So we will start our question. The question is, the haloalkanes undergo nucleophilic substitution, whereas haloarenes undergo electrophilic substitution. Usually this question may be asked for 4 marks. So we need to give a detailed explanation in order to get full mark. So before going into understand, we need to understand what is the difference between a nucleophile and electrophile. When you're considering a nucleophile, the nucleophile is basically a nucleus loving. Nucleophile is basically nucleus loving. That means a nucleophile, when you're considering a nucleophile, the nucleophile will be in search of positive charge. Nucleophile will be in search of positive charge. If something is in search of positive charge, means the nucleophile can be considered as it is an electron rich species. Electron rich species. If something is electron rich, means it may be either having a lone pair of electron, or it will be having a negative charge, having a lone pair of electron, or it will be having a negative charge. Hope fine. Okay. In the same way, when you're considering an electrophile, the electrophile is basically an electron loving. Something is electron loving means it is an electron deficient species, or it is a species with a positive charge. Okay, clear. So the nucleophile will be attacking an electrophile, or electrophile will be attacked by a nucleophile. So the first thing we were going to think about why haloalkanes follows or undergoes nucleophilic substitution. When you're considering a haloalkane, can take an example. A halogen is attached to a carbon. The halogen can be represented by X letter. It can be chlorine, bromine, or iodine, or fluorine. Anything can be there. So when you're considering this, these halogens are highly electronegative than carbon. That means there is an electronegativity difference between the halogen and the carbon. Due to this particular electronegativity difference, the shared pair of electron will be pulled towards the carbon. When the shared pair of electron is pulled towards the carbon, there was a mistake, please correct it. When you consider it, the halogen is more electronegative than, since the halogen is more electronegative than carbon, the shared pair of electron will be pulled towards the halogen. What is electronegativity? Electronegativity is the capacity to pull or capacity to withdraw the shared pair of electron towards it. So when the shared pair of electrons is pulled towards the halogen will be getting a partial positive charge. Since it is partially losing the electron density, the carbon will be getting a partial positive charge. Okay, so we can understand that when a bond is between a carbon and the halogen, since halogen is more electronegative than carbon, the shared pair of electron, or the electron pair which is present in between the carbon and halogen will be pulled towards the halogen. Since it is getting pulled towards the halogen will be getting a partial negative charge and the carbon will be getting a partial positive charge. Since it is getting a partial positive charge, it can act as an electrophilic center. That means a nucleophile can come and attack. So one reason is that generation of partial positive charge in carbon, that carbon which is bonded with the halogen. Clear? Then another thing is that when you're considering the halogens are better leaving groups. Halogens are better leaving groups. So when you're considering the halogen will be cleaved as X minus. Since it is getting a negative charge, since it is getting a partial negative charge, it would be very easy for the halogen to cleave as an X minus. Since the halogen is getting a partial negative charge, it is more easy for the halogen to cleave as X minus. That is why when a nucleophile is coming and attacking this particular carbon means automatically this particular halogen will cleave. So since this particular nucleophile is substituting the halogen, this is called a nucleophilic substitution. This is called a nucleophilic substitution. This nucleophilic substitution reaction can be happen in both ways. One is called SN1 pathway and the another one is called SN2 pathway. So depending upon the nature or depending upon the orientation of the reactant molecule, it will be following SN1 pathway or SN2 pathway. Depending upon which pathway the molecules are forming, the product will be various. That means someday we will be getting a mixture of products, someday we will be getting a single product. Those kind of things we will be seeing in another video. But in this particular thing, our focus is to explain that why haloalkanes are undergoing the nucleophilic substitution reaction. So the explanation is done. So when you're considering regarding the haloarenes, that means the halogen is attached to a benzene ring or an aromatic ring. The halogen is attached to an benzene ring or an the halogen is there. So when you're considering this particular halogen, what can happen now? This particular lone pair of electron which is present in the carbon, lone pair of electron which is present in the halogen can undergo conjugation with the pi electron cloud of the benzene by resonance. That means this particular lone pair of electron can get resonate between here. So this bond will get shifted to here. So what will you get? So you will be getting C double bond to C. Since the halogen is losing the lone pair of electron, so it will be getting a partial positive charge. This carbon will get a partial negative charge. Then there is a bond. The remaining bonds will be like this. So the next resonance will be like this. So what will you get? So you will be getting positive charge. A bond will be established. A negative charge. So a bond will be formed here, already existing bond. There will be a negative charge will be generated here. The last step. So what will you get? So the same structure will be re-established such that the pi electron clouds are re-established. So the halogen will be with the lone pair of electrons. So during resonance, you can say that, so what is happening? The lone pair of electron get conjugated with pi electron cloud of the aromatic system, correct? Aromatic system. As a result of it, you can see that a negative charge density is generated at the ortho and para position. As a result of it, a huge negative charge density is generated at this is ortho, this is para, this is ortho. So negative charge density get generated at ortho and para position. Negative charge density at ortho and para position. See, since as a result of resonance, the negative charge density is getting generated at the ortho and para position. So obviously it would be very difficult for a nucleophile come and interact because the ring is more enriched with electron density. So the nucleophile will not be interested to come and attack the benzene ring. But since electron charge density is getting enhanced at the ortho and the para position, since the electron charge density had been enhanced at the ortho and para position, an electrophile can come and easily attack either to ortho or para position. Either to ortho or para position. That means what happened? Since an electrophile can come and attack at the ortho and para position, by substituting the hydrogen present over there, by substituting the hydrogen present over there, so what can happen? It can undergo an electrophilic aromatic substitution reaction. So as a result of resonance, the negative charge density generated at the ortho and the para position, since negative charge density in the benzene ring increased, an electrophile can be substituted very easily at the ortho and para position. That is why the haloarenes are ortho-para directing in an electrophilic aromatic substitution reaction. In electrophilic aromatic substitution reaction, basically in the case of haloarenes, the electrophile is not substituting the halogen. Electrophile is substituting the hydrogen present in the ortho and the para, either in the ortho and the para position. Clear? So when you're considering in the case of an haloalkanes, due to the electronegativity difference between the carbon and the halogen, a partial positive charge is generated at the carbon. Due to the partial positive charge generated at the carbon, carbon can act as electrophilic sender. So a nucleophile can come and attack very easily on that particular electrophilic carbon. Also, halogen can cleave as an X minus, since halogen is a very good leaving group. Then, when you're considering in the case of an haloarenes, due to resonance, the lone pair of electrons present in the halogen can undergo conjugation with the pi electron cloud of the aromatic system. As a result of it, the negative charge density will be enhanced at the ortho and the para position. Since negative charge density get enhanced at the ortho and para position, an electrophile can easily get substituted at the ortho and para position by substituting the hydrogen attached to the carbon. Okay, that is why haloarenes undergo electrophilic aromatic substitution reaction. Haloalkanes undergo nucleophilic substitution reaction. I hope explanation is clear. In between the explanation, there was a small error happened, because in the beginning I said that due to the since halogen is more electronegative than carbon, the shared pair of electron will be pulled towards the carbon. That was a mistake. Please correct it. In the next part of the video, I have corrected it. But don't get mistake. Be very careful. Since between the bond between carbon and the halogen is more electronegative than carbon. So the shared pair of electron will be pulled towards the halogen. Halogen will get a partial positive charge and carbon will get a halogen will get a partial negative charge and the carbon will get a partial positive. Be very careful. Since halogen is more electronegative than carbon, shared pair of electrons will be pulled towards a halogen. As a result of it, the halogen will get a partial negative charge, carbon will get a partial positive charge. Hope the explanation is clear. If you need any further clarification, do let me know in the comment section. If you have any comment regarding the class, or if you want to say something, please do let me know through the comment section. If you are interested to see explanation regarding any other thing, any other particular topic or any other particular question, do let me know in the comment section. As a token of gratitude, please like to this particular video, share with your friends, subscribe to our channel. Also, I would like to tell you one more thing regarding this particular question. There is one more important aspect. Why haloarenes do not favors nucleophilic substitution? There are 3 to 4 points are there that we will be explaining in another video. I will provide you the link for that particular video in the description. You can watch that particular video also. Keep watching, keep learning. Thanks for watching. Bye.